This is about air pollution in Malaysia. And I will also talk about mitigation, how we can mitigate air pollution that I will discuss briefly with you. Can you go to next slide, please? From this slide, I want to discuss air pollution. When we talk about air pollution, it always comes to my mind that how good it is or how bad it is. It is because air pollution, it is a mixture of air particle, tiny air particle, and also a mixture of atmospheric gases. Some of the gases is very toxic. And from this slide, let's talk about the fundamental about air pollution. You can see some of the sources here I listed, I inserted at the bottom. These are the sources that always emit pollutant or atmospheric composition. And those atmospheric composition, as you can see on the top, I grouped two. One group is we classified them as a primary pollutant. And then on the right side, I have another group, and that group is listed as a secondary pollutant. And this pollutant, the primary pollutant, it always coming, the source I listed here, inserted here at the bottom. These are the source, not all about this source. On top of this source, there are numerous sources we have keep contributing atmospheric composition and atmospheric pollutant. Right, and on right side, the group of the composition I listed here, this group of composition in the atmosphere that throw a number of heterogeneous reaction, atmospheric reaction that is spontaneously occurring in the atmosphere, and then those are the mechanism. This secondary pollutant is always coming in the atmosphere. Right, can you proceed to the next slide? And if we talk about air pollution, this air pollution, not only we are having, we observe in Malaysia or in Southeast Asia, air pollution, this is a global issue. You can see from the picture here on the left side, Beijing in China, New Delhi in India, they always having like episode of air pollution in a particular time in a year. Everybody we know in New Delhi, they always observe winter fog. This winter fog is very deadly in New Delhi, particularly for the elderly people, because during this time, air pollution level is very high. And this air pollution level, as you see at the bottom in Indonesia, this is due to the biomass burning or forest fire. And this air pollution issue, not only we are having in Southeast Asia or in Asian cities, it is even observing in the continental cities. For example, London, Paris, California, and also in Sydney. Right? Do you know how many people died every year only because of the air pollution? For the current context, as you know, COVID-19, the pandemic that is already around the world, everybody we are having, right? Experiencing very deadly situation. Do you know how many people so far due to the COVID-19, how many people has been died? It is about 1.4 million, right? And then if we talk about air pollution, every year 7 million people died due to air pollution. It is about 5 times more compared to the current pandemic that we are observing. So this is how air pollution is having impact on our daily life throughout the world. So let's proceed to the next slide. Would you proceed next? And now let's talk about in Southeast Asia, what we are having in Southeast Asia due to air pollution. In Southeast Asia, as you know, we are having forest fire. And this forest fire always having in Indonesia, Malaysia, and Borneo side. And then once we have forest fire, the forest fire causes haze. Our visibility goes very down. From the picture itself, you can see visibility around the entire Southeast Asia is very low. This is because of the atmospheric pollution from this forest fire that causes the low visibility. And then that causes that impact on our daily life. in many countries like Malaysia, Indonesia, Thailand, local government, they need to shut down our school, college, and our business center, right? It has effect on our daily life. Can we proceed to the next slide, please? I want to talk a bit more about Southeast Asian biomass or transboundary pollution. And do you know this? The reason behind this biomass burning or forest fire, this is simply from the slide you can see, this is simply because of slash and burn. Uh, the slash and burn, it is a very common practice, very easy, cost-effective practice that our farmers who are doing farming, they make use, right? Once they have the farming waste, they simply burn, right? And that causes the Southeast Asian forest fire and eventually causes the biomass related forest fire related haze. If we go to the next slide, you will see that once we have that fire at the surface level, the fire simply doesn't be in the surface. The fire goes to the soil, very deep into the soil. And the reason behind is in Southeast Asia, many part we have here, our soil is kind of peat soil, right? Peat land. And then once the fire goes to the peat land, it started burning for days, even weeks, even months, right? And then this fire, not simply a fire. If we see in our next, can you click another click? You can see there is this. Can you click next, please? Yes. You can see once we have peat land, peat soil burning, this is a simple combustion reaction. And this combustion reaction is as simple as your chemistry student, mostly here, you know. But problem with this combustion reaction is if we have biomass burning or a peat soil burning, on top of this energy production, carbon dioxide emission, there are huge amount of toxic pollutant also emit. That is our great concern as a chemist, as an air pollution, like who we are working on air pollution. Can you go to the next slide? I want to show you here a number of combustion related process, forest fire, peat, soil and coal burning, all is combustion, right? And from this combustion, you can see at the bottom, I listed a number of pollutant here. From left side, you can see particle pollution in the form of black carbon, organic carbon, brown carbon, right? Primary organic carbon, secondary organic carbon. Secondary organic carbon, it is a like subject here in a topics in Southeast Asia. We really need to more focus on that because that causes many other secondary pollutant to generate in the atmosphere. One example is ozone, right? In Southeast Asia, this is one of the great concern, ozone pollution at surface level. And if we see a number of inorganic gases and organic toxic molecule even, once we have this kind of forest fire, pit soil burning, we always have emission of this pollutant. Can you proceed next slide? In the next slide here, I want to briefly explain about the insight, some of the composition. Due to the time constraint, I cannot explain more. I will go very quickly. Black carbon and brown carbon, as you know, it has impact, number one, on our human health, and it also impact on our climate because it is a climate forcer. Black carbon, it causes global warming. Brown carbon, it causes global, more like cooling effect, cloud albedo effect. Can you go next slide, please? In the next slide, we have the photochemical smoke. Do you know about photochemical smoke? This is kind of oxidant in the atmosphere. It generates through like heterogeneous photochemical reaction. And this oxidant, do you know how that generate? That generate if we have sunlight, oxide of nitrogen, volatile organic compound, these oxidant always generate. For example, ozone, other photochemical oxidant. Once we have photochemical oxidant in our ambient air, our sky become more like brownish in color. And that always we often experience, we often see in the Beijing and in Sydney, California. Can you go next slide, please? And then here I want to talk about particulate matter, particle, air particle, very tiny particle. And that tiny particle, how small this tiny particle, how small is small, that you can see from the slide here, the picture here, left side, if we compare with our human hair. Right, and then this tiny particle simply pass through our respiratory system and causes a number of respiratory related disease, and it also causes in our cardiovascular related disease. And recent studies has already established that this air particle can also pass through our bloodstream and come into our brain and can causes a number of brain related neurological disease. One of the commonly symptom that we often elderly people they experience dementia, memory, they simply lose memory. And this dementia or Alzheimer kind of disease, it is often due to the exposure of this tiny particle. Can you go next slide, please? Here I want to show you the effect of air pollution in Southeast Asia. Do you know how many people died in Southeast Asia only due to the biomass burning in 2015? 100,000 people died. I have given a list of reference here. If you are more interested, I would ask you to go over this reference, and you can come to know more about those effects in Southeast Asia. Can you go next slide, please? Here, I want to introduce you a new thing about mitigation of air pollution and how we can do mitigation. We can make use approach here. This is called Chemometrics Approach, and Chemometrics, I believe, is somewhat new, could be for you, but this method is quite helpful to identify the hotspot of air pollution. Can we go next slide, please? In the slide here, the chemometrics, what is chemometrics? You are already familiar now, right? It is an algorithm modeling. And how does it work? At the beginning, we need to have measurement and chemical analysis in our lab. And during our measurement chemical analysis that we often do in our project, right? And that always give us a set of data. Right, that set of data we can make use in this chemometrics model, and this chemometrics model will help us to identify the hotspot for the pollutant. Can you go next slide here? I have given here a number of receptor model, chemometrics model. I have given link. If you are more interested, you can go over the link and you will come to know more about this model. You can make use in your work. Next slide, please. In the next slide here, two slides, one by one. One is PMF, one of the best and appropriate model, robust model. It is because this model, if we make use in chemometrics to identify the potential source of the pollutant, our calculation will have less uncertainty, less error. So this is widely accepted for current context. And in the next slide, I have another model. Can you go next slide? In the next slide here, this is one of the simplest model, PCAMR. And this model, you can simply make use even with your very limited data. The problem associated with this PCAMR model, this model will have high uncertainty, right? Error will be very high. In that case, there is another approach called absolute principal component score. So this approach is somewhat like advanced and will have less uncertainty. We often use absolute principal component score for our chemometrics modeling. Can I go next slide? I have given here like some of our result during strong haze, and next slide I have moderate haze. And in these two slides, you will see during a strong haze time in Malaysia, the potential source that we can see biomass burning, right? Secondary organic aerosol, those are the potential source during haze episode. And we also have a number of studies. We made comparison during Haze time, data from Cheras, Kuala Lumpur, Muar, and also data from satellite data from Sumatra. We made a number of comparison, and we have visualization here. You can see pattern of the pollution. It is somewhat similar, no matter the height, the like level of the pollution, but pattern is similar. So it's simply saying that pollutant, once we have biomass burning, forest fire in Sumatra, it is impacting even in Malaysia. Can we go next slide? During the moderate haze in Malaysia, we also identified the number of pollution source here, and we made a number of validation by using some other model, cross validation, and we identified coal-fired power plant, biomass burning, and transportation are the potential source in Malaysia. And then go next slide here. Can we go next slide? In the next slide, next two slide, I just have briefly want to introduce you the air pollution trend in Malaysia. In the next slide, can we go? We have been using here, carbon monoxide and PM10. Carbon monoxide and PM10, if we see the about 20 years trend here, for the very top bottom, on the right bottom slide, you can see for the Malaysia, overall Malaysian CO trend, you can see CO trend is steadily increasing, right? Can we go next slide? And then if we compare with the PM10 trend over last about 20 years, you will see at the very bottom the overall data for Malaysia from about 48 stations that we have here. We summarized data and we found that PM10, it has been decreasing in the early 2000. However, the yearly trend is started increasing steadily in the last few years. Can we go next slide? So the summary here is Indonesian biomass burning or Malaysian biomass burning from our local scale biomass burning, and also Malaysian Borneo biomass burning. This is the event that every year causes haze in Malaysia. And what are the approaches that can make use to mitigate? Descriptor modeling or chemometric modeling could be one of the best model. Cheaper and cost effective and much simpler, and some of the result here I already discussed, and in my understanding that oil plant management of the land use transportation in Malaysia, Borneo and Malaysian Peninsula can assist Malaysia to be more environmentally sustainable. Can I go next slide? Here I quickly want to, next slide please, quickly want to announce here that we are having a micro-credential course. The course name is Chemometrics in Air Pollution. This course online soon under The website will be Future Learn. So everybody here, you are welcome to join our micro-credential course. This course will give you briefing and introduction about air pollution and how we can mitigate air pollution. So thank you everyone. Even though the time I had interruption, I hope this insight about the problem, air pollution problem in Malaysia, the insight about this problem and the chemometric approach that will help you to have your better understanding. Thank you everyone. Thank you so much.
All right. Thank you so much, Dr. Firoz Khan, for your speech. I would like to conclude a bit from what you said. So basically, air pollution in Malaysia is not only mainly from the gases emission from the industry, but mainly from the farming as well. That happens occasionally, and these two incidents definitely have bad impacts toward our health, especially the respiratory systems and the inhaling of the particles itself. And we actually have a question asked in the chat box. Is from Leong. He's asking, what do you think about the job perspective that chemist graduate can look into when it comes to air mitigation as part of environmental chemistry industry? So what's your opinion about that, Doctor?
It's a very good question, since these topics this subject is quite new in environmental science, particularly in Asian context, atmospheric science, air pollution issue, and mitigation strategy that we have been working with. This is somewhat new issue, but I can see there are a lot of scope to work on. Many things we can work out. Southeast Asia particularly, this is a hotspot for some of the atmospheric pollutant, not only pollutant, some of the composition cause that is responsible for air pollution or health impact. Some of the composition in Southeast Asia, that's the hotspot, can causes emission of greenhouse gases. So I can see there are a lot of scope can be worked out, uh, because eventually that is impacting on our health, right? Once something you will work out can help to mitigate our health issue,
Mm-hmm.
local issue, regional issue. So there are obviously there are scope, there are career opportunity around.
Mm-hmm.
I hope we really need many people to come out from Southeast Asia. So
Mm-hmm.
that's simply I can say. One example I can just tell you here.
Mm-hmm.
I have been talking about, say, Southeast Asia biomass burning, right? This is a
Yeah.
tropical area, right? Tropical rainforest area, and
Mm-hmm.
rainforest, it is a hot spot for some of the organic compound emission. For example,
Understood.
like isoprene, terpene, it is coming from Southeast
Understood.
Asian rainforest, right? So this
Understood.
isoprene, terpene, it is not simply organic compound, right?
Mm-hmm.
They have a lot of impact on atmospheric chemistry, and eventually that
All
impact
right.
on our local scale air pollution. So once it will impact on our air pollution, it will impact on our health, right?
Very true.
So
Very
so
true.
so we need people who are from medical science, who are engineering
Mm-hmm. Mm-hmm.
background, who are from mathematical background, programming background. There are a lot of people can work out and can have opportunity in. I mean, if you are interested to work, if you are interested to work on air pollution, so no matter you are a chemistry background, like if you even you are the programming background, there are a lot of scope, like in atmospheric science, air pollution, a lot
Mm-hmm.
of scope for programming. So in my sense, I would say, particularly for Southeast Asia, you have a scope. I would say that you just try to grab.
Understood. Understood. Yes, all right, doctor. There's another question, and how do we decide on developing the most suitable models for the air monitoring? Do you have any comment about that?
Yeah, I mean, it is as simple as we can see. Since we are working on this model, we know still there are scope that, for example, in Southeast Asia, there
Mm-hmm.
are a number of satellite data source in Southeast Asia. As you know that if we want to do measurement in our lab or analysis in our lab in Southeast Asia, we simply cannot have a lot of budget to buy instrument, right? So in that sense, see if somebody here who are interested to work on modeling, right? So they can develop model. So
Mm-hmm.
data we have in the satellite source. So they can simulate the data and make use the data for our public, for our government, for our general people, right? So there are a scope that modeling people, they can I mean, they have a scope that they can do work on uh, modeling in air pollution.
All right, doctor. Last question. Last question.
Yes.
Just now you mentioned about chemometric modeling. So can we actually use chemometric modeling in air pollution to help in coming up with a warming indication on the haze occurrence?
Right. I mean, chemometrics, no matter which like topics you are working with, chemometric, this is a very generalized term, and chemometrics you can make use once you have data, right? If you work in the lab, always we have a set of data, right, at the end. So that data we need to work out, right, to simplify our data for presentable or for our thesis writing, for our publication, right? So these are the chemometrics model can help us. So no matter it is in air pollution, or no matter it is in environmental other pollution, or no matter it is a set of data like could be climate related data or any data, you can make use chemometric on your own way. So I'm working on air pollution. Yes, chemometrics helps me a lot to work out my data. Is that okay with you?
Uh, yes, Doctor. All right. Thank you so much, Dr. Muhammad Firoz Khan, for spending time with us to share with us about your research, and thank you so much for your informative sharing session from you.
So thank you everyone. Thank you so much. It was an interruption. So so thank you everyone. It is very good to share with you all. So I wish our next presentation session will carry on smoothly. Thank you everyone.
All right. Thank you. All right. So if the participants, if you have any questions, you want to contact Dr. Firoz Khan, you may contact him on his email. You can contact him through Gmail or through his email, basically. All right. Thank you, Doctor.